So as Dame Julia King highlighted earlier today, hydrogen could play a key role in areas where we make the largest amount of greenhouse gases, such as transport, energy supply, business and residential. So hydrogen is potentially zero emission energy vector and chemical feedstock. For instance, it could be produced using renewable electricity by electrolysis, then converted back to electricity with fuel cells. So the demand for hydrogen is set to increase by at least a factor of 10, both in the UK and globally. However, what's important to bear in mind is that hydrogen right now is not sustainable. So 95% is from steam-reformed fossil fuels, only 5% from electrolysis. So right now, the current production makes enormous amounts of CO2. So we want it to be more sustainable. So let's move to the next slide. So we did the consultation of 20 academic institutions and national labs and 6 companies looking at developing new materials for hydrogen. So move to the next slide. So we have identified 6 technologies where the UK materials community can really make an impact. So we look at these first 4 technologies, all different kinds of electrolyzers. So on the right, you have a schematic of a proton exchange membrane electrolyzers. So all of these technologies, I've proposed different opportunities and challenges and different degrees of technological maturity. However, common to all of them, you either need better catalysts, as shown in the insets on the top right here, or better electrolytes or better electrodes, or a combination of all 3 of those. So regardless, materials play a critical role. So right now, hydrogen is used to produce chemicals like ammonia or ethanol in large-scale thermochemical reactors at high pressures and high temperatures. That's a very steady state. So if you get electrolytic hydrogen from solar and wind, it will be produced at low pressures at constantly varying rates. Hence, we need new catalysts and other materials that operate at low pressures and low temperatures for thermochemical synthesis. Alternatively, we could do away with molecular hydrogen altogether and produce these chemicals by the direct reduction of nitrogen or CO2, as Nora discussed earlier. Again, we need better catalysts, electrodes, and electrolyte materials. So it's important to emphasize, actually, the advances and methods and understanding that we use for one of these technologies are often directly transferable to the other technologies. Likewise, as Jenny and Robert emphasized earlier, improvements in electrolytic energy storage improve the viability of solar power, for instance, by decreasing the impact of the intermittent supply of solar or wind. Likewise, materials used in solar cells could also be used in photoelectrolytes. So there's a lot of cross-cutting activities that would benefit all these different areas. So let's move to the next slide. So what we require is state-of-the-art facilities, world-class scientists and engineers, and a lot of integration across the UK and academia and industry, and also strong integration into international partnerships, research programs, and value chains. So one thing that we came out of our road mapping exercise, we noticed there's a big discrepancy between lab scale testing in academic labs and the full cell electrolyzer testing that's done on the stacks in the industry. So material that works well on the lab scale doesn't necessarily work right now well in industry. So we need routes and facilities for the testing of new materials at single cell prototype level to bridge this divide. So move on to the next slide. So there's enormous opportunities for the UK in this area. We already have really leading companies in electrolyzers and fuel cells, and also production of materials and catalysts for hydrogen production and fuel cells. So we also have enormous potential for renewable electricity, particularly for offshore wind, as you can see in the figure on the right. And hydrogen allows us to store this. So hydrogen is particularly attractive, again, as Julia King mentioned before, for decarbonizing some of the areas that are most difficult to decarbonize, such as heavy-duty vehicles, or for heating, or for an industry, production of steel, methanol, and ammonia. So if we build up a strong homegrown industry in the UK for hydrogen, we can become Europe's leading exporter of hydrogen. Thank you for listening.